Today we present differences between the problem of freezing in the thin pipe, compared to the freezing of the thick pipe in air conditioning. On screen, we observe the animation of the operation of an air conditioner. In this video, we will focus on the freezing problem of the pipeline, in split-type equipment. 1. Let's start by saying that, in a split-type system, there are no high-pressure pipeline outside. Both lines are low-pressure. This is because the high-pressure pipes are located inside the external condensing unit. 2. The smaller diameter line, also called the liquid line, connects the capillary tube to the evaporator or indoor unit. It is responsible for carrying the liquid refrigerant to the evaporator to absorb heat from the room and cool it. 3. The larger diameter pipe, or vapor or gas pipe, is responsible for returning the refrigerant from the indoor evaporator unit to the compressor. This refrigerant has absorbed heat from the room, so it is in a gaseous or vapor state. 4. If the thin or liquid pipe is freezing, the cause of the problem may be a lack of refrigerant or obstructions in the capillary tube. 5. When there is an obstruction in the capillary tube, the temperature in this part of the system drops significantly, even reaching freezing. This behavior is abnormal since the normal temperature of the capillary should be close to the external ambient temperature, maybe a little cooler. 6. Over time, when the equipment is turned on, the obstruction in the capillary tube causes a gradual reduction in current consumption, but not immediate. This is because the compressor gradually stops compressing refrigerant, as the obstruction holds it in the condensing unit. 7. If the equipment failure due to freezing of the thin pipe is solely due to a lack of refrigerant, the amperage consumption will be low all the time. Even shortly after turning on the equipment, in this aspect, measurement can be taken with an ammeter clamp. Additionally, when there is a lack of refrigerant, freezing or cold does not concentrate specifically in the capillary tube. 8. The lack of refrigerant causes an immediate pressure loss once the equipment is turned on. Remember that the normal working pressure of R32 and R410A, with the equipment on, is above 120 pounds per square inch. 9. If the thick or vapor pipe is freezing, the failure occurs in the evaporator. This is because the evaporator is responsible for supplying refrigerant to the thick pipe and receiving heat. 10. Problems in the evaporator can be caused by dirty air filters, a dirty turbine, or low fan speed of the turbine. 11. In case of dirty filters or a dirty turbine, it is recommended to clean the indoor unit. If the fan speed is low, check the type of motor of the fan. If it uses a capacitor, it can be tested by changing it, to see if the fan speed recovers to normal values. It is worth noting that a low speed of the fan motor can also be due to motor bearing issues.